Good afternoon, everyone. I hope you all have been enjoying TechEd so far. Welcome to Cluster Shared Volumes Reborn and Windows Server 2012. My name is Subhashish Bhattacharya. I'm a program manager in the failover clustering team. Presenting this session with me today is Steve Winfield from NetApp. Before I get started, a quick show of your hands. How many of you all have CSV deployed in production today? Wow, awesome. So I'd say about 40 to 50%. Y'all are going to like what we have for you in CSV 2.0. For the rest of y'all, I hope over the next 60 to 75 minutes, I'll be able to drive home the advantages of deploying CSV in your clustered environment or in production. Feel free to stop me and ask any questions. I know it's a reasonably sized room, but I'd prefer an interactive session to, say, Death by PowerPoint. And the second thing, to try and make you stay for most of the session, I'm giving out a few copies of Clustering for Dummies. So hopefully that's incentive for you to stay around. What I have for you today is I'm going to start off with an overview of what Cluster Shared Volumes is. We are going to talk about what's changed in Windows Server 2012. Throughout the course of this session, I'm going to try and piece by piece convey our new architecture for CSV. We've made multiple performance enhancements. I'm going to dig deep into each of them. And I think a lot of you all would agree with me. Backup was kind of a pain in 2008 R2. We've worked hard to improve our infrastructure. I don't know about you guys, but if someone came up to me and told me, hey, we've improved backup and whatever, there are ping fairies and fluffy sheep, I'm going to tell them, hey, I'm an engineer. Show me if you've really improved it. So we've requested our partner from NetApp to demonstrate how our enhancements in the backup infrastructure can lead to a quality experience in your CSV backup. So what is Cluster Shared Volumes? CSV is a clustered file system which allows the nodes in a cluster to have simultaneous access to a LUN. You can think of it as a layer of abstraction on your NTFS volume, or maybe going forward on some other file system as well. But what does this bring you? Given that all nodes have access to a single LUN, it means when you are failing over your workload, you no longer need to mount and dismount your volume. So you have a more transparent failover experience. What pain points does CSV help solve? Now, before the LUN was the smallest unit of failover. By that I mean if you wanted to failover, say, Hyper-V independently, you'd need to dedicate a LUN to Hyper-V, and then when you're failing over, you'd need to mount and dismount. So if you had 100 instances of Hyper-V, you'd need to have 100 instances of your LUN. Now with CSV, you can get around that. You can consolidate your Hyper-V instances on a single LUN. Before, for all practical purposes, you were stuck with 24 drive letters. And once you used all of them up, you had to resort to stuff like volume GUIDs. With CSV, we are exposing a consistent namespace where you do not have drive letter limitations anymore. You'd run into situations where you had one LUN with gigs of storage, and you were struggling to fit capacity in a LUN. Now with CSV, you're consolidating your LUNs and utilizing them more effectively. And the normal issues of managing multiple LUNs, multi-path, and all other issues. Let's take a walk down memory lanes. We first introduced CSV in 2008 R2. So you guys might have, once you all install CSV, you would have seen this pop up. Hey, do not use CSV for anything but Hyper-V. You use it for anything apart from Hyper-V, bad things will happen. So here's the story around that. From our whiteboard in Redmond to your production environment, in just about 12 months, we delivered CSV. For a feature of this kind of complexity, that was indeed a pretty dramatic velocity. So to do this, we decided that we'd have to narrow our scope. So we decided that we are going to support Hyper-V. We'll figure out which file system APIs we need to get working to support Hyper-V. What I/O patterns we need to optimize for to support Hyper-V again. We implemented CSV as a mini filter driver way above on the file system stack. What that did was it would intercept I/O. Either it would send it straight down to disk.sys, or it would orchestrate it over the node which owned the NTFS volume, which we call the coordinator node. Our motivations for 2012 for CSV. We wanted to make CSV more general purpose. We wanted to support more than Hyper-V. One of the major workloads we are supporting in 2012 is the file server workload. In 2008 R2, for your backup, as soon as you kicked off a backup, we would move the NTFS volume to the node where you started the backup. We'd be in redirected mode for the duration of your backup. Your backup application needed to call custom CSV, VSS APIs. So we worked to fix all of that and deliver a better experience. To improve performance, we took a twofold approach. We decided we are going to be smarter about when we are in redirected I/O mode. And when we are in redirected I/O mode, we wanted to be more efficient, more performant. You must have heard of storage spaces. Essentially, what you're doing is you're lumping together a bunch of JBODs, creating a storage virtualization layer on top of it, carving out virtual disks, so storage spaces, and those are completely integrated into clustering. So you could add these storage spaces to CSV. Finally, CSV in 2012 has multi-subnet support as well. When I think about CSV in 2008 R2 and 2012, it almost seems to me like a couple of oranges. You look at it from the surface, PowerShell, failover cluster manager, WMI, they seem very similar. But once you dig deeper into the core, you'll realize that CSV 2.0 is dramatically different. In fact, CSV 2.0 is a complete rewrite. Now we are no longer a file system mini filter. We are actually mounting a CSVFS proxy file system. What this allows us is better interop with file system and volume filters. Because before, what was happening was we were directly routing I/O either to disk or to the coordinator node. And we were bypassing everything else in the middle. Right now, your antivirus filters will be able to attach to the CSV proxy file system, so they can interrupt with us. Same thing for your replication solutions or your continuous data protection solutions. Your backup vendors, they now no longer need to pull all the heavy weight. I mean, CSV is doing a lot of the work that they need to do. It's much more easier for them to interrupt with CSV. A huge win in 2012 is application consistent backups. So essentially, imagine you have 100 VMs sprawled over all 64 nodes of your cluster. you can kick off a snapshot on any node in the 64-node cluster, and we are going to do the work to ensure that you have an application consistent backup. I wonder if some of you all have noticed that when you all would go access the CSV volume on a non-coordinator node, sometimes it could probably hang for a bit. So what was happening there is we are using SMB as our transport for CSV. And we were using the cluster name object, or the CNO, as the shared identity. So for that, we would need to contact a domain controller. And if your domain controller was misbehaving, we'd stall for a bit. And this was exacerbated even more if your cluster node was accessing a remote domain controller or a flaky domain controller. You could run into a state where redirected I/O would completely fail. So in 2012, what we have done is we've removed this dependency on AD. What we are using now is local user accounts on each node of the cluster, and we are keeping them synchronized. We now support memory mapped files. How many of y'all are using BitLocker encryption for your clustered disk right now? Anyone? So before, in 2008 R2, BitLocker was just supported for our traditional physical disk resources. In 2012, we are now supporting BitLocker on cluster shared volumes as well. So what this gives you is an additional layer of protection for your data center. A low cost and easy to configure solution as well, I'd add. And we are now integrated with all the new great file system features, such as copy, offload, defrag, spot fixes. So now let's gradually start thinking about the new CSV architecture, piece by piece. Nothing new in this slide, but I want to start off from, I guess, the baseline. So any clustered file system, say any solution, not just CSV, needs some kind of mechanism for metadata orchestration. Some solutions do it on the storage side. You're probably familiar with VMFS. What CSV does is it orchestrates metadata on the server side. So you have a node, the coordinator node, on which the NTFS volume is mounted. And all the other nodes, when they need to carry out metadata operations, they orchestrate it through the coordinator node. Oh, it's on that. Oh, I see. Sorry about that. Anyway, I guess the first node is the coordinator node, and you're orchestrating your metadata updates through the node on which the NTFS volume is mounted. And one of the differences between doing it on the server side versus on the storage side is you have lesser issues like lock contention, and you have a more scalable solution. What I wanted to add is metadata updates are operations like creating your VHD, powering on your VHD, stuff like storage migration, live migration, just the duration when you're creating your snapshot. So the takeaway is that these are small, infrequent operations. So you do not need to be unduly perturbed about going into redirected I/O mode for these operations. And one more thing I'd add is that CSV volumes are per LUN. So what this gives you the ability to do is you can spread out, you can distribute your cluster shared volume coordinator nodes across the nodes of your cluster. So what this would do is essentially you are parallelizing your redirected traffic So here's the most part of our new CSV architecture. There are some simplifications which I'll dig deeper into later on in this presentation. So we have our coordinator node in the middle. We have a CSV proxy file. Let me give this another shot. Okay, so we have a CSV proxy file system stack mounted on all the nodes. We have a CSV file system filter, which is routing traffic to the NTFS volume. So right now, in 2012, the NTFS volume is going to be hidden. We are going to be exposed as CSVFS. In this diagram, you can see that one of the nodes does not have visibility to the SAN. So we are running in an asymmetric configuration. And what's new is in 2012, you can see this line going directly from the CSV proxy file system stack to the disk. I'll dig deeper into this later on. But just remember, this is one of the changes in the path or the mode of redirection in 2012. The rest, I mean, it's kind of similar to what we had in 2008 R2, except now our mechanism for detecting if we are going to be in redirected I/O or direct I/O is different. You can think of the mechanism in 2008 R2 as being kind of static. For example, the mode at which you opened your file. In 2012, it's more dynamic. So you could be in redirected mode for a single operation, get out of redirected mode, come back. So it depends on what operations the other nodes are performing as well. Setup is vastly simplified, and it's been integrated into the cluster manager and other tools. So for example, you no longer have a separate storage pane for CSV. You do not need to enable the feature. I mean, you just go to a volume you want to add in, right-click on it, that's it. You've added it to CSV. Like in 2008 R2, you still have a consistent namespace exposed to you. It's exposed under C:, cluster storage, and then you have your volumes exposed as mount points. That's one difference I'll talk about right now. And you could rename these mount points. For example, you could go to volume X, call it business VHT volume, or anything that's convenient for you. In 2008 R2, we used reparse points. What this caused is you were running into interrupt issues. For example, if you were going to Ops Manager, you're trying to figure out how much free space you had for a CSV volume. You weren't able to do it. You were bringing up perf counters. You couldn't directly use C:, cluster storage volume. You had to use the volume GUID. So now that we're using mount points, all these interop issues should have gone away. We are now exposing CSVFS volumes transparently. So what this essentially means is that before what would happen is to an application, it would show, the CSVFS volume would show up as NTFS. And CSVFS, while it's a layer of abstraction on NTFS, it does display some characteristics of a remote file system. So an application wasn't really very sure what it's operating on. Right now, they know exactly that they are operating on CSV. After that, they can decide, hey, we know that we've supported CSV, so we know what we are going to do. Or they can decide, hey, we know we are running on CSV, but we are going to put a hard block on CSV. But either ways, the behavior is consistent and transparent. I have a quick demo on, I have a quick demo on how we add volumes to cluster shared storage in 2012. So first, I'm going to show you I have a VHD on an existing cluster shared volume. So it's consistently displayed on node 1. Sorry about that. So I'll start again. I have a 2-node cluster here, and I have a bunch of volumes here. One of them is already added to cluster shared volumes. I'm hosting a VHD on that. So as you can see the VHD on node 1. I go ahead, I can see it on node 2 as well. And now let's go back and see what this volume is displayed as in Disk Manager. So before, in 2008 R2, this would be exposed as NTFS. Right now, since we are actually mounting a CSVFS file system, that's what we are exposing it as. I've created a storage pool here, and I have one virtual disk or a storage space. Let's see how I can add it to CSVFS. Just right-click on it, and that's it. That's all you need to do to add a volume into CSVFS. Now let's go back to my storage disks, and I have a bunch of them on available storage. Let me multi-select all these guys. So 5 disks. I want to add them to CSV. Right-click, add to cluster shared volumes. That's essentially all you need to do to add a volume to CSV in Windows Server 2012. I guess, it's just so simple. Even your grandmom can add a volume to CSV in 2012. A common question that we sometimes get is, hey, why should what's the value prop for me in my production environment or in my cluster? Why should I deploy CSV? Is it just a clustered file system? I think what we highlight then is the resiliency you get out of CSV. This is something some of the other solutions out there, solutions like VMFS, don't give you. So with CSV, you have I/O fault tolerance for node failures, network failures, HPA failures. So let me explain how we go about doing this. Say you have a VM running on CSV. What we do is we virtualize the application handle. And then under the covers, we open the handle to NTFS. What this allows us is, if we notice some kind of a failure that we need to remedy, we are able to pend I/O on the CSVFS filter. Once we've remedied the failure, we are able to flush the I/O and continue processing. So what this results in is that failover is transparent to the application if you choose to have it. Let's run through a few scenarios. Let's say we have a 2-node cluster. Both of them have access to the SAN. You're in a hurry. You trip through the fiber cable to one of the, your non-coordinator node. So we are going to detect it, and we are going to route your I/O through the Ethernet, through the coordinator node, to your storage. Now let's say your coordinator node crashes. We have heart-beating packets being sent every second between the nodes of a cluster. Once we see a few missed heartbeat packets, we are going to detect that this node needs to be kicked out of cluster membership. Our regroup algorithm is going to get kicked in, and we are going to choose a new coordinator node. And while this is happening, your I/O is going to be pended on the CSVFS filter. The new coordinator node, the NTFS volume is mounted on the new coordinator node. The node announces its presence as the new coordinator node. All the other nodes reestablish their SMB connection to this node, and then we flush the data, and we are able to continue operation. So, I mean, what if we didn't have this kind of a mechanism? If you were running your Hyper-V on your storage, it would have just bug checked. But in this case, you're able to continue running your application without any downtime. In 2012, we are using SMB multi-channel to determine which networks we are going to stream our CSV traffic through. But what we have as a backup, in case SMB multi-channel fails, is that we are going to go back to our 2008 R2 mechanism of using paths determined by our NetFT virtual adapter. So what is this NetFT virtual adapter? If you go to your cluster node, go on ipconfig, you would see a cluster virtual adapter. What this is doing is that it's determining fault-tolerant paths between all the nodes in your cluster using the existing network interfaces available to your cluster. So if one of these network paths failed, we would then float a CSV redirected traffic over an alternate path in your cluster. So I want to quickly show you a scenario where I'm going to I'm going to try and let's get this up. I have the same two-node cluster here. I have my VHD on cluster disk 7. I'm running Windows 8, Windows 8 VHD. On that, I have this video of a couple of cute docs from my buddy. What I'm going to do here is I'm going to start streaming my video. And if you notice right now that the coordinator node is node 2. And what I'm running, these nodes are iSCSI initiators. And what I'm going to do is I'm going to go over to my iSCSI target, and I'm going to yank off node 2 from it. So keep your eyes on 1, the video, and so we have, I apologize for the quality, but these are running off my boxes in Redmond. So here's my node. I go to my iSCSI target, and I'm going to remove node 2 here quickly. OK. And let's get back here. So it's still node 2. You see the I/O being pended briefly. I/O was pended, and then what we did was we detected that, and then we flushed. So for a brief moment in the video, you notice that the dogs kind of stalled. So what was happening there was we were queuing our I/O on the CSVFS filter. We moved over the NTFS volume to node 1. Node 2 no longer has connectivity to the storage, and we essentially have a zero downtime guarantee for this application. I'm sure in some of the, this is probably not the first time you're hearing of the continuously available scale-out file server in 2012. So instead of repeating what you've already heard in a bunch of sessions already, I'm going to take a cluster-centric view of the scale-out file server. So what cluster pieces went into building a continuously available scale-out file server? Piece number one, you know that CSV is now supporting the file server role. So we are using CSV to synchronize or make sure that all the nodes in the cluster have access to multiple SMB shares. Or let me step back a little bit. Before in 2008 R2, for your highly available file server, you had a single cluster name. And you were binding that cluster name to a file server. When you wanted to fail over, you were unbinding, moving the file server over. In 2012, we've added a new distributed network name resource. So what we are doing is that for a single network name, we are registering multiple IP addresses with DNS, and we are binding them. And we also have a new cluster resource called the distributed file server. So right now, say you have another cluster, say a Hyper-V cluster, and it wants to run over SMB. We are using DNS round robin to choose a SMB connection from your cluster of SMB file shares. So what does this give you? So when one of your file servers fail, I mean, firstly, you have the flexibility. Since you have a cluster of file servers, you can easily add in new file servers or remove them. But when you have a failure, using the mechanism we talked about, CSV resiliency, we are able to detect and migrate the application, in this case, the Hyper-V or, say, SQL connection, to another file server. So what you have, and what's a huge win with a scale-out file server, is that now you have a zero downtime solution for both planned and unplanned migration. If someone came to me and told me, hey, what's one reason I should get Windows Server 2012? I think the check disk improvements is one of them. Before, if you would go to your buddy and say, hey, I'm thinking about getting a 4 terabyte hard disk, they tell you, are you insane? Check disk is going to take days to run. Not anymore. In Windows Server 2012, you no longer need to live in fear of check disk. The check disk operation has been divided into two. You first have an online operation where you're scanning the files and detecting corruptions, and you have an offline operation where you are actually fixing the corruptions. But this just takes, I mean, in seconds, maybe less than 3 seconds. So the pain of having to have your disk offline while check disk is running is no longer there. So let's look at this performance graph. You have the number of files in your x-axis and the amount of time it takes in your y-axis. As you can see in Windows Server 2008 R2, I mean, it was in the order of hours. And in 2012, you can hardly see it because it's less than 3 seconds. So where does CSV fit in? The great thing is that we've integrated these check disk or spot disk improvements into CSV. Or more specifically, the CSV is alive health checks. So as you guys probably know, we run detailed health checks on physical disk resources every minute. So during these health checks, we are going to check if any CSV FS volume has corruptions. And we are going to take a call and determine if we can fix these corruptions without impacting the availability of the application. If there are too many corruptions, we are just going to wait for the next disk online before we try fixing the corruptions. Now let's dig a little bit into our performance improvements. Let me remind you, our approach for improving CSV performance were two-phased. One, we are going to be in redirected I/O mode only for as long as we need to be. And two, when we are in redirected I/O mode, we are going to be more efficient. In 2012, we are now integrated with the Windows Cache Manager. The Windows Cache Manager caches read and write I/O for traditional buffered I/O. So in 2008 R2, it wasn't really that much of an impact because, I mean, we only supported Hyper-V, and Hyper-V is unbuffered I/O. But what's the biggest win, I think, in CSV in 2012 is the CSV block cache. Have you guys heard of a Fusion I/O card? So that's a hardware implementation of a cache for unbuffered I/O. What we have built in Windows Server 2012 is a software implementation of it. So we have built-in a cache for unbuffered I/O by reserving system memory, so your RAM, up to 20%. So actually, not we reserving it, you guys have the option to reserve it. And in our tests, we've determined that round about 512 MB is the sweet spot for cache performance. So what sort of scenarios would derive value from it? So unbuffered I/O, clearly Hyper-V, read-intensive operations, VDI operations. And I mean, we in the product team are kind of surprised in a way to see how performant this has been and what sort of performance improvements we've been seeing so far. For example, one of our most critical customers in 2008 R2, he sent us an email. I mean, obviously, first I saw the email as like, duck. I mean, can't be good news. But then what he told us was that he was amazed by the performance he was seeing after he enabled CSV block cache for his VDI deployment. Without block cache enabled, his VDI set was performing at around about 50% of local desktop. He enabled block cache, and it was performing on par with local desktop, and in some instances, even better. So I guess I don't know about you guys, but for me to believe something, I'd need to see a demo. So I have a small demo coming up next of CSV block cache. So what I have here is a 2-node cluster. I have 100 VMs. 50% of them, or so 50 of the VMs, are running on volumes which have CSV block cache enabled. 50 of them, obviously, are running on volumes which don't have block cache. So the VMs which have the index VMA are running on block cache. The VMs which have the string VMB are not running on block cache. I have about 80 of the VMs already running to keep the cache warm. So the first thing I'm going to do is I'm going to go ahead and I'm going to connect to 2 of the VMs, so one on block cache and one not running on block cache. And I'm going to start these VMs. So let's see which starts first. So note, what would be ideal for us is we would need to be able to, we would want all the services to be up and running, and we'd want to be able to log into it. So I'll give VMB a 1-second head start. So I start this, and then I go ahead and start this. So this guy is good to go, and VMB is still taking its time. It's ready, but a little later. CSV block cache. So now I'm going to go ahead, and I'm going to start eight more VMs. This is going to be a little bit more tougher to see because it would almost seem like they might be starting at round about the same time unless you actually go to the VMs and check them out. But let's see what happens. Yeah, I mean, this one isn't as clear, but if you did actually go to the VMs, you'd see that the block cache VMs did actually finish starting first. The next portion what I'll show you is I want us to observe the read queue length. So this is an indicator of the performance you're getting out of for the volume. So the longer the read queue length, the worse it is for your application. So in red, I have the volumes which are not running on CSV block cache. On green are the volumes using CSV block cache. And now I'm going to go ahead and I'm going to start the remainder of my VMs. So as you can see, the red is already spiking up, and you can imagine the impact of this on your application performance. And there you see the green going, and you have the red spiking up. So this essentially is the impact of the CSV block cache. I think this is one of the huge value-add features in Windows Server 2012. And I'd recommend you investigating using CSV block cache for your cluster deployment or as you go into into production. I think for those of you all who are curious, I'd sort of add in another element. The way we are using our block cache, we are sort of allocating 50% of it for LRU cache and 50% for a LRU2 cache. So what does this mean? Essentially, if you have I/O which is very random, so LRU stands for least recently used. So when a block is hit a second time or multiple times, you are going to move it to the LRU2 cache. So if you had some very flaky I/O, which was keeping on oscillating, what splitting the cache in this way is going to ensure is that you do not have cache thrashing. So that's one more element that went into while designing the CSV block cache. As I sort of indicated, in 2012, we want to be in direct I/O for as long as we can. How are we going to do it? So in 2008 R2, our mechanism was kind of static, kind of determined by the scenario or the state when we started the operation. So that kind of resulted in scenarios like backup, where you were in redirected I/O mode for the whole duration of the operation. In 2012, we are using opportunistic locks. So let me talk about how this works, say, in a common scenario like extended writes. So that's where you'd be copying your VHD. If you were copying your VHD into a non-coordinator node in 2008 R2, what would end up happening is that you would be in redirected mode for the entire duration of this operation. What will happen in 2012 is that we are going to be in redirected I/O mode for only the metadata portion of the copy. After that, the non-coordinator node is going to request the write opportunistic lock. And as long as it has access to this lock, it's going to know that it's fine for it to be in direct I/O mode. Similarly, you'd have scenarios where the node would request the read opportunistic lock. So that would kind of indicate to it that it's okay for it to read the data in its local CSV cache. That's different from the CSV block cache. So if you got into a scenario where two nodes requested a write op lock, then, obviously for the duration when both requested this lock, neither would have access to the lock and we'd be in redirected I/O mode. But once the operation for one of the nodes finished, then the other node would gain access to the op lock, and it would be able to continue in direct I/O mode. So here's the piece I was kind of insinuating to in our first block level diagram. What would happen in 2008 R2 was that we would first traverse the stack on a non-coordinator node. And if we didn't have access to a storage connection, or we were running in an asymmetric configuration, we would go redirect our I/O over SMB to the coordinator node, and then we'd have to traverse the NTFS stack again. What we do in 2012 is instead of traversing a file system stack twice, we are sending the I/O over SMB to an entity. I'll get into that entity in a couple of slides. So what we end up happening, and what we've seen in our test results, is that we have 2 times performance we are 2 times faster than what we were in 2008 R2. In 2008 R2, what we were using is the file system redirection mode, and this is block level redirection. And we have a third mode of redirection called file level redirection. In 2008 R2, we never ran into a scenario where 2 nodes would want to have shared access to a file, because, hey, we are supporting Hyper-V, and you'd have one node wanting access to a VHD at a moment. But now, since CSV is more general purpose, you could well have 2 nodes wanting shared access to a file. So as I described using the op lock mechanism, where 2 nodes are requesting access to the right op lock. So that is file level redirection. File system level redirection is what you are familiar with in 2008 R2. You could go right now, click on a CSVFS volume and put into file level redirection. Maybe you wanted to perform some maintenance on the node where probably fix some sort of connection to the SAN. So that's sort of planned redirection. And block level redirection we just talked about. This diagram is a bit of an eye chart, and I'm not under any kind of illusion that you'd read through it, all of it in these next 1 minute or so. But you'll have this slide deck at the end of this session. And this is the CSVFS architecture with uncensored. So the part I'd like to focus on is the part where I've circled, or rather block level redirection. Okay, so we come down the pseudo file system stack. As you can see, the third node does not have connectivity to the storage. So we'll walk down the CSVFS stack on node 3. We are going to determine that we do not have connectivity to the storage. We are going to redirect I/O block level through SMB to the SMB server, and it's going to be sent to the CSV namespace filter. This filter has the smarts to determine that this is block level redirection. We do not want it to traverse through the NTFS file system stack a second time. It's going to route this I/O directly to disk.sysc, and it's going to be sent to the storage. CSV has leverage all the gains of SMB 3.0. So SMB is using optimizations such as RDMA and copy offload. And so essentially SMB that you're used to is for a certain workload. If it had around about a 27% performance of DAS, or direct attached storage. What we've noticed in 2012, with all the improvements, SMB is actually operating at 98% of DAS. So CSV redirected I/O mode running on SMB is less of a fear factor now. And we are, as I mentioned, we are using SMB multi-channel. So we are setting up, I mean, if there are multiple network interfaces available, we are setting up multiple SMB sessions to stream our I/O. So you put all these pieces together. You have, I mean, the point here is that redirected I/O is less of a fear factor in 2012. A common magical question that we get, I mean, quite often from VMware customers who are sort of used to like a page of restrictions as to what they can do with their VMFS volume. So how many VMs are allowed per CSV volume? On our side, we do not have any restriction. That's because we are using server-side synchronization. But think about what's happening here. You have a LUN which you are saturating with IOPS. I mean, so can your LUN handle the IOPS which we are flooding it with? I mean, in 2008 R2 or before, probably it wasn't an issue, but think about now. You have 64 nodes and potentially 4,000 VMs on it. So that's quite a bit of traffic. So our recommendation is that you talk to your storage vendor. Ask them if they handle and what their statement is. Some of them will tell you, hey, we have the smarts built into our I/O controller. We are going to route your IOPS to a certain tier of storage. Some would tell you that you need to probably invest in a higher level of your software array. Some might need to do some computations. But from the CSV side, there are no restrictions. That said, you have a trade-off here between having connectivity to your storage and say your network bandwidth. If you want to have some nodes which are smart on compute intelligence but don't have connectivity to the storage, what essentially you are playing with is that it might be more advantageous for you to split your workloads over multiple CSVFS LUNs, because I mean then you're having your IOPS being sent through SMB sessions in parallel to different coordinator nodes. You're using SMB multi-channel, so maybe you need to think about how many 10 gig NICs you have based on your asymmetric configuration. So let's talk about backup. As I mentioned, a huge improvement is the support for distributed app consistent snapshots. You have 100 VMs sprawled across your 64 nodes. You start a snapshot. The CSVFS writer is going to be responsible for talking to all the CSVFS proxy writers across the nodes with a Hyper-V writer in there, and it's going to orchestrate the snapshot that's being taken. And therefore, you're going to have an application-consistent snapshot. Now you can have parallel backups. You can start multiple snapshots on the same node for multiple CSV volumes on multiple nodes. In 2008 R2, you had a disruptive backup experience. No longer. I mean, you start off your snapshot, your NTFS volume stays on the node where it was before the backup. And as you can imagine, because right now we are going to be in redirected I/O mode only for the duration when we are creating a snapshot. For the rest of the backup, we are going to be in direct I/O mode. So this will result in better performance. With all the infrastructure changes, backup applications no longer need to call CSVFS VSS APIs. They can just call the standard VSS APIs and they are able to interop with us. I think a key pain point which I've noticed across in the forums is, I mean, you were wondering in 2008 R2 what backup applications or what vendors support CSV-FS backups. I mean, it was sort of a mystery with several posts across forums. I have talked to about at least 18 vendors in the last months or so. And the story is way better in 2012. Many vendors are good to go right now. Some are going to be ready in a few months. But at the very least, they have a story in place. So for example, vendors like our own Microsoft Data Protection Manager, or Windows Server Backup, or maybe Symantec's Backup Exec, or Net Backup, or EMC's Networker, or RecoverPoint, solutions from IBM, HP, Altero. So the point is that you have a plethora of options in 2012. One of the solutions which is ready today is a solution from NetApp for Snap Manager. Over the last 2 years, we have worked closely with NetApp to make sure that our CSV-FS backup improvements are actually solving the problems that you had in 2008 R2. So on to Steve to give you a demo of how a backup application can result in a significantly improved CSV backup experience for you.
Hello. Hello. So we asked at the start of the session who was using CSVs, but my question is, who's using 16-node Hyper-V clusters with 1,000 VMs? Okay. Okay. So this is for. I mean, where we've been working is at large scale. So I have got customers with 16 nodes running, thousands of VMs in there, and the whole backup thing becomes quite challenging because back in the day when we had a physical server, that physical server has its own NIC. That own NIC's connected to the network. You put a backup agent on there, and out it goes. The challenge you've got is when Microsoft and the virtualization guys allow more VM density per host, and you put 30, 40, 50 VMs per host, you have to install, or some people install an agent in that host, and then each host is backing up through that stack, but you've only got the one network stack. Now, we can still do, 10 gig Ethernet and everything else, but the likelihood of putting agents on each of these VMs and backing that up and having then your backup solution is just diminishing. You have to back up at the Hyper-V layer now at large scale. And the other thing is, who does the backup? In the old days, the VM belonged to the Wintel kind of guy, and he was responsible for doing the backup of that VM. Now the kind of VM is virtualized. Whose responsibility in the organization is it? Is it the guy in ops that manages the hypervisor, or is it the guy that is in charge of the server? So who gets that responsibility? So we've been working with these guys in terms of even plugins for System Center. And if you saw the System Center session on Tuesday, in terms of the advancements in SP1, we're actually leveraging the Open API now in terms of the GUI, so you can leverage backup within SCVMN on NetApp to take a snapshot at the back end. The other thing is when it comes to who's responsible for doing that backup, it all depends. So the fact that we've enabled the Data on Tap PowerShell toolkit across NetApp, you can use PowerShell to do pretty much anything on our array and plug into these backup tools. So if you wanted to, you could say someone creates a virtual machine, they go into System Center Service Manager, that goes and gets an authorization request, the VM gets approved, it comes back into System Center Virtual Machine Manager, the VM gets created. But then if you wanted to, you could create a PowerShell script which created a backup job in Snap Manager of Hyper-V and also backs up the VM, all automated in System Center Orchestrator. So you can glue all these things together now to produce a solution for you, because everybody's going to be different in the room in terms of how they want to back up. There's no one right answer. So we've also done kind of policy-based backup. So all VMs aren't equal. So maybe the finance people want their VMs backed up every hour, every 2 hours, every 4 hours. Or maybe the test dev guys don't want to back up at all. Maybe some other guys want just to back up once a day. Maybe some people want to back up and then send that VM across site to a backup destination, and then also want a script to have that VM created and then mounted against that LUN, and you're ready to go as well from a DR perspective if you wanted to do that. So we group things in these data sets in terms of the backup application. Okay, so the Snap Manager for Hyper-V uses this new VSS CSS rewriter and VSS CSS provider. Now, why is that important? Because if you had a Windows 2008 cluster and you had 16 nodes, you're doing things one thing at a time. So we back up this node, we go to the next node, we map the CSV, we back up this node, we go to the next node, we map the CSV. And while we're doing this, we're in redirect mode until all the backup's done and then we come back out. In Windows Server 2012, this is all done in parallel. So on the owner node, or the coordinator node, he says, OK, I'm going to call a backup, and I'm going to talk to all the other nodes in my 64-node cluster, or however many nodes you want in there, and he's going to say, are you ready, guys? Yes, we're ready. Snapshot taken via the VSS framework. We're all done. So we're not walking into each node. So we're basically parallelizing the VSS kind of framework in order to take a backup of multiple VMs on the cluster. So there's either a lot of people in this session because the lunch isn't very good, or because they wanted to go. So bear with me, because a lot of people tend to just agree with me when I'm going through this slide, but it does take a little bit of kind of getting used to. So at the top, we have kind of Snap Manager for Hyper-V, and again, you can drive that with PowerShell or via the MMC. And this talks to the backup node, the owner node of the cluster, okay? And within there, we install a service, which is the VSS requester. So our software is acting as that VSS requester. That then talks to the VSS service in Hyper-V, which talks to the Hyper-V writer. The Hyper-V writer then talks to this new CSV writer, which is the enhancements that are in Windows Server 2012. That then coordinates to all the other nodes in the cluster. And in this case, on the demo I'm going to show, it's just a 2-node cluster, and talks to the Hyper-V writer in there, which then talks to the CSV provider, which talks to the Hyper-V writer to say, back up these VMs and back up these VMs, go to the data on tap hardware provider, because we're a VSS hardware provider, take the snapshot on the back end, and we're done. So I know it seems quite kind of complex in terms of, but just think of it, it's just a parallel backup mechanism for all these things. We're not walking via each one. So you want to see it? Yeah. Okay, here it goes. Okay, so what I've also done here is just shown, we've got a 2-node cluster. I'm just on the 1 node here. And you can see there's a number of VMs running on Demo Server 1, and a number of VMs running on Demo Server 2. Some VMs are also switched off. There's no I/O going to it. It's just a kind of, there's VMs that we're going to back up. Okay. Now inside there, you'll also notice this status symbol here in terms of what is actually happening with these VMs as we kick the backup off. And what I'm going to do is show you the fact that each of these 2 nodes in the cluster is backing up VMs at the same time. It's not like do this one, this one, this one, jump to the next one, do this one. It's going to do it in parallel. So into the Snap Manager for Hyper-V GUI, here, we're going to go into the Protection tab, and you'll see that there's already a data set created. So we're going to create a data set just for the sake of this demo. Oops. And click Next. And we're going to give that a name, and we'll call that TechEd Demo. TechEd Demo. Okay. It's now going to say, what VMs do you want as part of this data set? So we can choose which VMs you want in there. So again, based on the importance of the VMs, for argument's sake, so I'm not going to back up, in this instance, any temporary VM just for the sake of it. So you can choose what you want to do. You can have departmental. You can prioritize what they want to do or anything else. So there's my backup data set created. Operation successful. So now that's created, let's go and take a backup of all those VMs. Okay. So I can give it a backup name. I can set a policy type. I can also say whether I want application consistent or crash consistent. So do I want to be able to kind of bring that application, do I want an application-based VSS backup, or just want to say, I want a crash-consistent backup? So in this instance, we're going to do application. Click next. Okay, how long do I want to keep those backups for? So maybe I just want to keep kind of a 24-hourly rolling, so I can go back to, any hour in the last 24 hours on the last day. I can bring the VM back to any point in time. Do I want to delete backups or clean them up? I'm just going to go through that. Do I want to update a snap mirror? So snap mirror is NetApp's kind of way to replicate data from one storage controller to another. So I can take this backup and also say, shove it over here and over here and over here at the same time. Or I can bounce them with snap vault or snap mirror, or a combination of things there. So I'm going to leave that just as it is today because we haven't got a snap mirror operation running in the back end. And I've got summary. So when I click finish now, before I do that, I can look at the PowerShell script. So I can automate this into System Center Orchestrator or whatever we want to do based on the PowerShell backend. Click finish, and it's going to go off, validate my backup request, and start the backup. So it's executing the backup. So while we look now at the status of what's going on here, as things start to run on the cluster, you'll see that these VMs are backing up. And as they're backing up on the node, I'll flip across it, they're also backing up on the other node. So these are all backing up. It's not a do this one, come out and redirect, do this one, come out. It's doing it in parallel. And I can't kind of stress that enough because that's the benefit of moving to Windows Server 2012 to enable kind of large-scale backup of VMs on this platform. So just as we're still backing up, we're going to be going through all those processes that I talked before, put the machine in, are we good to go? Yes, we are. All via the VSS framework, and if anybody's kind of familiar with the VSS framework, you have to respond with, yes, I've taken the backup within a certain time frame, and keep going through there. And as we go through, come on. Still running. Even they liked it. I'll come back to that. I'll come back to that in a second. But there we go. Oh, bear with me a second. Can we put your PC back on? Put your PC on just for a second. Connections dropped in here.
It's never mind. Let's
yeah.
wrap it up.
Can we go back to it?
Yeah.
We can come back to it in a second. I'll just flip the thing and show this. The connection just dropped. But basically, the whole point there is that the parallelism of it is just allowing large-scale backup of Hyper-V at a larger scale throughout that. So let me just get the connection back up, and I'll flip back to the screen.
Okay, thank you, Steve. Oops. So to wrap things up, as you can see, we've significantly improved CSV in Windows Server 2012. I mean, if you guys had some concerns with 2008 R2 and it's not fixed in CSV 2.0, I want to know about it, and our whole CSV product team wants to know about it. We have support for more workloads. CSV is more generalized. Performance should be significantly better. So I hope all of you in this room today would agree with me that CSV is a core infrastructure to facilitate your private cloud solution in your workplace. I'd like to thank all of you all today for taking the time to attend this session. I know it's not easy to come down on a Friday afternoon when you're trying to get back home. And I wish you a safe trip back home, and thank you for attending. Before I open the field for questions, I just wanted to mention a couple of quick things.
This one?
Yeah. A couple of resources for you. Our failover clustering blog, where we are churning out articles about Windows Server 2012, and our failover clustering discussion forum. All of us PMs are out there. We have cluster MVPs. So that's a great place to sort of keep in touch with us. Obviously, you can take my business card after this, but we are all there in the failover clustering forum. And the second thing is about evals. I mean, I personally hate filling out evals, but we take these evaluations incredibly seriously. I read all of them. And we've just had 2 cluster sessions this year in TechEd, but this is your forum. If you want to see less cluster sessions, more cluster sessions, you want to see something different in these sessions, you want us to improve in some way, this is the way you can do it. So please, please, please fill out the evaluations. Thank you.
Do you want to see it? Yeah. We'll just run another one, yeah? So off we go. There we go. And there we go, succeeded. So you see each one coming off one at a time. Backup succeeded. And we're done. So no smoke and mirrors, honestly. The connection did drop. I can't do anything about that, I'm sorry. There you go. Thank you.